In this video, we're continuing with our discussion of the chain rule. We're on page 2. So first, the chain rule. It says if you have a function f of x, it's a composition function. So we're going to think of the function f of x as a composition of the outer function f of t and an inner function t of x. When you compose the two together, you change the variable t to the function t. You now have f of t of x. And that composition function would input variable x and output f of x. So if we have a function that can be broken down into an inner and outer function like this, a composition function, then the derivative of f of x, df dx, the derivative of f with respect to x, is the derivative of the outer function, df dt, times the derivative of the inner function, dt dx. So let's go ahead and go through a few examples and give it a try. So part of this process is going to be breaking our function f of x down into its pieces, f of t and t of x, just like we were doing on the previous page. So in example 1, we have a function 3 times negative 8x squared minus 7x to the third plus 5 times negative 8x squared minus 7x squared plus 4. Hopefully you can clearly see that there is this inner function, negative 8x squared minus 7x. And recall, we call the inner function t of x as we do our side work. Then we can go back to our function f of x, and everywhere we see the expression negative 8x squared minus 7x, we can replace that with t, because that is the function t of x. Now we can look at our function and see that it is 3t cubed plus 5t squared plus 4. That is the outer function, 3t cubed plus 5t squared plus 4. Once we've found the outer function and the inner function, we now are going to find the derivative of each. So we have f of t. We're going to find the derivative of f of t, df dt. That's the derivative of the outer function. That'd be 9t squared plus 10t. And notice the derivative of 4 is just 0. We also need to find the derivative of the inner function. So our inner function is t of x. We're going to find its derivative, dt dx, derivative of t with respect to x. That'd be negative 16x minus 7. Remember, in our side work, just like we were doing on page 1, we also want to come back here to the derivative of our outer function, and we want to replace those t's with the expression t of x. 9t squared plus 10t. Everywhere I see a t, I'm going to replace t with negative 8x squared minus 7x, because that's what the function t is equal to. All right, now the chain rule tells us the derivative of that original function, f of x, the derivative df dx, is found by taking the derivative of the outer function, df dt, times the derivative of the inner function, dt dx. And those are the two pieces we just found. We're going to take df dt, so we have 9 negative 8x squared minus 7x squared plus 10 times negative 8x squared minus 7x. That's 9t squared plus 10t. We're going to take all of that entire function, times dt dx, which is negative 16x minus 7. Be very mindful of your parentheses. It's a very common error for students to lose the parentheses, but the chain rule says it's this entire expression times this other entire expression. So you do need to have parentheses around both. Let's try example 2. Example 2, we're given a function f of x equals 30e to the 4x. Again, note, it's not just the basic exponential function 30e to the x, it's 30e raised to an entire function. that exponent, 4x, is the inner function. So I call 4x that inner function, t of x. Everywhere I see 4x, I can replace it with t. So really, this is 30e to the t, which is our outer function. We then need to find the derivative of the outer and the derivative of the inner. Derivative of 30e to the t is just 30e to the t. And again, remember, you got to replace your t with the expression for t. So 30e to the t becomes 30e to the 4x. And the derivative of our inner function, 4x, is just 4. So overall, using the chain rule, the derivative of f with respect to x will be the derivative of the outer function times the derivative of the inner function. So df dx is 30e to the 4x times 4. Let's try example 3. Example 3 says we have the function f of x equals ln of 7 minus 11x cubed. Notice this is definitely an inner function. T of x, the inner function, is 7 minus 11x cubed. So everywhere we see that expression, we can replace it with t. So our outer function is just ln of t. Again, we need to find the derivative of the outer function. Derivative of ln of t is 1 over t. We're going to replace t with the expression that t is equal to. So 1 over t becomes 1 over 7 minus 11x cubed. That's the derivative of our outer function. And we need to find the derivative of the inner function. Derivative of 7 is 0. Derivative of negative 11x cubed is negative 33x squared. That's the derivative of our inner function. And so, overall, using the chain rule, the derivative of f with respect to x will be the derivative of the outer function, 1 minus 7lx cubed, times derivative of the inner function, negative 33x squared. Notice you can go ahead and multiply fractions straight across the top to get negative 33x squared times the derivative of the bottom, 7 minus 11x cubed, if you like. In example 4, we have a function f of x equals square root of 7 plus 5e to the 0.04x. Before we dive into finding the derivative, every time we have a square root or cube root, we definitely want to rewrite that expression for f of x. So square root of that expression is really that expression raised to the 1/2 power. Now when I view this f of x function, I can clearly see there is an inner function, t of x equals 7 plus 5e to the 0.04x, and this outer function, t to the 1/2 power. Again, we got to find the derivative of the outer function, which would be 1/2 t to the negative 1/2, and derivative of the inner function, derivative of 7 is 0, derivative of 5e to the 0.04x. Careful there, it's not just 5e to the x, it's 5e to the function of x. We did a problem just like that a moment ago. When we have 5e to the 0.04x, that would be a derivative 5e to the 0.04x, but then you have to multiply times the derivative of that exponent. That's the derivative of the inner function. So that's a chain rule inside of a chain rule problem. Over here, we have the derivative of the outer function, 1/2 t to the negative 1/2, and we always got to go in and replace that t with what t is equal to. So in this case, it'll become 1/2 times 7 plus 5e to the 0.04x raised to the negative 1/2. That is the derivative of the outer function. And over here we have the derivative of the inner function. Putting it all together with the chain rule, the derivative of f with respect to x becomes 1/2 7 plus 5e to the 0.04x raised to the negative 1/2 times 5e to the 0.04x times 0.04.